Hi, I'm Christophe and I'll be explaining to you the physics behind powerlifting involving 3 compound exercises: bench press, deadlift, and squat. Powerlifting is a competitive sport where athletes attempt to lift maximum amounts of weight as possible. We'll be looking at the conventional lifting techniques employed in these 3 exercises and also explore alternative lifting techniques to reduce total work done but still lift the heaviest weight possible. For demonstration purposes, all loads shown on this video are comfortable weight for the lifters.
The deadlift involves lifting a weighted barbell off the ground from a squatting position to an upright position, working the erector spinae, gluteal muscles, hamstrings, quadriceps, latissimus dorsi, and trapezius. Conventional deadlift involves a stance with feet shoulder width apart and hands beyond the feet like this. To reduce total work done, a sumo stance is used where the legs are widely spread open and feet pointed outwards. This posture reduces the total distance travelled by the bar. The bench press is an upper body exercise working the pectoral muscles, deltoids and triceps brachii. It involves lowering the barbell till it touches the chest and pushing it back up to its original position with elbows extended. Conventional bench press is done by pushing the bar up in a vertical plane. To reduce work done, we use the inclined plane theory by moving the bar in a horizontal plane and also by arching the upper back and retraction of the scapula. The squat involves bending the knees until the thighs are at least parallel to the ground, then standing up again, all while being weighed down by a barbell. It works the erector spinae, gluteal muscles, hamstrings, quadriceps, and calves. A conventional back squat involves placing the barbell on the shoulders, also known as the trapezius. However, to reduce total force applied and hence overall work done, the low bar squatting position, where the barbell is lowered and positioned on the posterior deltoid instead is used. The low bar position decreases the length of the lever arm from the bar relative to the hip. The lever arm is the distance on which the bar acts on the hip along the back. The hip is the point of rotation, while the force to rotate the hip is the barbell. Reducing the lever arm distance reduces overall torque of the barbell. Let's compare the work done for setups of a conventional deadlift and a sumo deadlift. Let the force of the barbell be a constant F, while the distance travelled by the barbell from the ground to lockout position be D. So in a conventional deadlift, there's a longer distance travelled by the barbell. So therefore, work done is F times D equals to FD. However, in a sumo deadlift, as the feet are split wide apart, the distance travelled by the barbell from the ground to lockout position is reduced. So in a sumo deadlift, let the distance be 0.7 times of D with respect to distance travelled for a conventional deadlift. Therefore, the work done is force times 0.7 D equals to 0.7 of FD. This is clear proof that less work is indeed done in a sumo deadlift compared to the conventional deadlift. The lifters shown in the video incorporated both inclined plane press and arch back methods. However, let's take a look at the inclined plane method first. Let's take the mass of the bar as 200 kg. So for the force required to lift the bar for the conventional vertical press, the force output is calculated to be 1960 newtons. Now for the inclined plane press, let the angle that the weight is lifted be at 45 degrees. So for the force required to lift the bar for the inclined plane press, the force output is calculated to be 1385 newtons instead. So by comparing the two forces applied, the force required for the inclined press is 71% of the force of the vertical press. Now, let's take a look at how the arch back method can reduce work done. Let the force of the barbell be a constant F and the distance of the flat back setup be D. So for the flat back setup, the work done equals to FD. With the arch back setup, the distance travelled by the bar from the chest to lockout position is reduced. So now, let the distance travelled by the bar be 0.6D in the arch back setup. So for the arch back setup, the work done is now 0.6 FD. So this is a clear indication that the work done for the flat back setup is more than that of the arch back setup. In conclusion, pushing the bar back and creating an inclined plane will need lesser force than pushing the bar vertically upwards. Also, by arching the upper back and retracting the scapula, the distance between the bar and the chest reduces, thus minimizing work done and effort used. For the lifter to successfully lift the barbell, the torque exerted by the person must at least be equal to the torque of the barbell. Let's compare the force applied by a person for the setups of high bar and low bar squats. Let the depth that the person is squatting be a constant lowercase d, force of the barbell be a constant F, and the lever arm distance be an uppercase D. So for the high bar squat, which is a conventional high squat, there's a longer lever arm distance. So we calculated that the force of the person required to lift the barbell is FD over D. With a reduced lever arm distance, let us now look at the low bar squat. For the low bar squat, there's a shorter lever arm distance. Let the lever arm distance now be 0.75D with respect to the lever arm distance of the high bar squat. So therefore, we calculated that the force of the person applied when using a low bar squat is equals to 0.5 of the original force.